Good afternoon all. Welcome to the Autodesk webinar, and the topic for today is AutoCAD 2016. We thank you for making the time to attend the session. You can post your questions in the chat box throughout the presentation. The questions would be answered during the Q&A session post the presentation. Our presenter for today is Mr. Sanjeev Ghosh, Technical Specialist, Autodesk India. He will take you through the new features of AutoCAD 2016. Over to you, Mr. Sanjeev.
Thanks, Vidhi, and welcome everyone to today's session on AutoCAD 2016. Today's session is in continuation to the earlier webinars that you might have already attended, and if you have already attended a few of my sessions earlier, you would have already come to know what the new features of AutoCAD 2016 are broadly. So today I'm not going to go through all the features, all the new things that are there in 2016, but I'm going to try and cover two specific things in a little more detail with a little bit of hands-on and try to show it to you with some examples. The features today which I'm going to discuss today are the feature of being able to use point cloud data inside AutoCAD. Okay, and the feature that using the new coordination model workflow. So these are the two things which I'm going to cover in a little more detail. And so let's move on to my AutoCAD screen now. So here we are in AutoCAD. And let me open my demo data. Format, which has come to me from a laser scanner. So this is the model here, and we could open and leverage point cloud data even in earlier versions of AutoCAD, but in 2016 we have added some new functionality where we can extract information from these point clouds for more enhanced workflow. So I am going to start. So for the purpose of showing this demo, since the point cloud is a 3D model, I have switched over to the 3D modeling workspace, which is different from the drafting and annotation workspace. So the tools that you see on the top, the panels that you see are for you see this solid surface, mesh, and visualized panels, which otherwise you would not see in the drafting and annotation workspace. So the moment I click on the point cloud here, I get a contextual ribbon bar that gives me more tools to specifically manipulate point cloud information. Okay, things that I can are only relevant to the point cloud file of point cloud data. So these become visible to me the moment I click on this point cloud. How did I get this point cloud? I could get this point cloud by attaching a point cloud file from a scanner that came to me from a third-party agency. So this was not modeled in AutoCAD. This is a as-built data or a scanned data of a real site. Okay, so this is what a point cloud is. Now, what are the things that I would want to perhaps do with a point cloud? Okay, of course, I want to visualize the as-built state of some location. I want to do measurements. I want to really find out how things were built, things that cannot be measured using conventional methods. I want to actually bring inside a design tool and maybe make some modifications to it or build something additional on top of it. This is what I may want to do with this point cloud information. That is why we may want to use a point cloud in our workflows. So before I get into the depth of the point cloud, let me show you this new section plane tool. So with this new section plane tool, I can actually create a section plane. As you see that the moment I created my section plane, the model has been sectioned at the section plane that I just created using the section plane tool. When I click on the section plane, I get a contextual ribbon bar for the section where I can do a few things with the section. Like the first button which you see on the left here is for the live section, where I can switch it on or off. So as I am switching it on or off, you see that the sectioning is now switching on or off. So I can, disable or enable section using this section plane. Also, there is a new feature that has been added to the section plane. So the section plane is not entirely new; it was there, but there are a few new things that we can do now with the section plane. I can actually take a slice of the geometry. Okay, so I can slice the 3D model. The 3D model which can contain of point clouds, which can contain of solid models, which can also contain of other solid geometry, can be sliced. Slicing is, taking out a thickness out of the entire solid model at a particular location. So that location is defined here by this number. So this is the position of my slice. Okay, so I'm going to slice it at a distance of 10. So you saw that the section plane actually moved slightly upwards at that distance, and I'm going to slice it for a thickness of again 10. So now you see that with this sliced information, I can actually see my model at that section particularly, as if I have drawn a line. Okay. This will be a little more clear when I actually rotate the section and see a vertical section of the same model here. And let us, if I drag the section, you see that I can see the sliced section at the section plane for a thickness of 10. So using this slice section plane command, I can actually look at any section in my point cloud the way I would actually want to have a look at any section of a solid geometry. So this is how I can section a point cloud using the section plane. But what else can I do here with this? I can additionally generate. So why would I want to section? First of all, let us understand that. I would want to section because I want to leverage this section information for creating something new or modifying something that exists, or simply take out the printout for this section and document it. So that is what I want to do perhaps. So so just looking at the section may not be enough for me. Okay, so it's good to see the section, of course, but I want a little more. So in 2016, we have added a very, very interesting and a very a new functionality where we can actually extract AutoCAD geometry from this section of a point cloud data. So if you see in my contextual ribbon bar here for the section plane, I have this last tab here which says generate, and under generate I have an option to extract section lines. Well, I have two options here. One is generate a section block, and the other is extract section lines. So the generate section block is something which I will not discuss in detail here, but I'm going to show you the extract section lines now. Just to let you know what generate section block will do is generate section block will create a block out of the section of a solid model. Okay, a 2D block. That is what a section generate section block will do. Whereas extract section lines will actually read the solid, read the point cloud data and generate a 2D geometry from the point cloud data on the section plane. So let me use the command and show you. So the next thing that I have to do is select the point cloud, and this dialog box that you see now, the extract section lines from point cloud, lets you select a few more things, like whether I want only the perimeter or whether I want the entire cross section. I am going to select the entire cross section. There are a few additional things like how accurate you want, or how how properly you want, because this takes some time to calculate and compute. So depending on how much time or how much accuracy you want, you can take this slider ahead, and of course it will take a little more time. So I'm going to keep it somewhere in middle here, and some other information like these extraction tolerances is something that you can set. The minimum line length for the lines or polylines that are created. Okay, so this I am going to set to 2 inches, and the or maybe I'm going to keep this to 6 inches here, and I'm going to so there's another tolerance here which says connect line tolerances. So this is the tolerance which specifies how the distance between endpoints of the generated lines. So I'm going to put this as at 6. Sorry, I'm going to put this as at 2 feet, and I'm going to say create. So this preview result is something which is very helpful, because if you are not sure whether what you're going to get is correct or not, this may be very time consuming. So this preview result gives you a very quick result to let you know what the actual outcome will be. Based on that, you can, if you're not satisfied with the preview, you can make changes to these values and again see a preview before you actually accept the results. So I'm going to say create now. So you see on this right hand side bottom corner, you see an update bar. Is actually doing something for me. It is actually processing. And once the processing is over, I will actually get a preview. So depending on many things like how many points are there in the point cloud, what is the density of the point cloud, and so on, the time for calculating the section lines may vary. So this is very subjective, and also it may vary based on the computing power that you have. So this is a CPU-based calculation that is happening. So based on the power of your processor, also this may vary. So it's almost done, and we should see a preview soon. So if you see, I have got a nice preview, and it has actually calculated 2D geometry for me at this section. This may not be exactly usable, but the way you may expect it to create straight lines, arcs, and so on. But the usefulness of this is that this gives us reference geometry for us to create a more refined and accurate geometry by on a, so this entire geometry is on a 2D plane because we had initially created a section plane, and this geometry was created at that section plane, at that level of the section. And it asks me, do you want to accept the results or change any settings? So I can either say S for going to settings, or I can say accept, or I can press A and press enter. So I got a section plane. I got a section. I got section lines extracted, and let me delete this section plane for the time being, and also let me hide. The point cloud. So you see that the 2D geometry has been extracted. This is the 2D geometry that was extracted at that section. And as I said, this will give you reference information for further developing the accurate layout. Okay, so you can actually use this by using this as a reference for further creating the actual section. So this is really very good. I personally find a lot of uses for this, and this can be used to leverage very nicely to create objects from a point cloud. So let me end object isolation, and let me actually again select this, and let me isolate the point cloud only, because I want to show you some more things on the point cloud. And let me change the view from a perspective to orthographic. Now I have this point cloud. It is a very huge point cloud, and we may also handle larger point clouds in AutoCAD. But how do I control the performance of this point cloud? There are many ways. Like if I go to the options and I go to the 3D modeling tab in options, I see that I can actually define what is the maximum point cloud that are displayed in my drawing. So I move it down to minimum and I just apply, and you will see that the point cloud has now become less dense, and the performance will definitely be better than better as compared to the complete point cloud with all its points being shown. But if I have a very fast computer, I have a very powerful computer, then I can actually stick to a higher size. Okay, I'm going to stick to a higher size here, and I'm going to let it remain dense. Also, I always don't need to go inside the options, but as I click on the point cloud, I again get this contextual ribbon bar where I can specify things like changing the density or the level of detail of the point cloud. Okay, so I can make it lighter. Again, this will affect performance. It will sort of make the pan zoom rotation much faster. Also, I can increase the point size. So, even if I have less points, I still see a very dense point cloud, which gives me a feel of seeing a very, very real point and almost an image-like quality of the point cloud. Now, the few things other than this that I may want to do is, when I'm working on point clouds, I may be working in different areas or different sections of the point cloud at different times. I am not working on the entire point cloud at the same time. So I need a way by which I can actually segregate a point cloud, an area in the point cloud, and be able to access it at different times. So if I click on the point cloud, again in the contextual ribbon bar of the point cloud, I have this area where I can crop a point cloud. So I'm going to use a cropping tool here to crop it. But okay, I can crop it, so I can actually create a rectangular crop, which is good. I can just crop this and save it as something, as a named cropped area, and I can uncrop all, and I can always access that cropped state. But this looks pretty cool because I can separate this, but I see a small problem when we create a drawing on paper, and before constructing things, when we are creating a drawing, we create everything based on some reference lines, okay, the XY grid. And if I had created this in AutoCAD, I would not, let me change the perspective to orthographic. So let me, so this is the orthographic view. If I would have created this and modeled this, this would not be inclined. Okay, so I want to be able to align it properly. So how can I align? So this, let's see a new function in AutoCAD. Let me undo a lot of things that I did, and there you are. So we are back to the model, and I believe I don't have the section which I created. So there are no, I don't have that rectangular cropped section saved. I have undone it. So I want to properly align this and place it in my 3D space aligned with my X, Y, and Z axis, as well as the X, Y, Z, and Z explains properly, so that when I draw things, when I draw a rectangle, for example, it is properly aligned to the edges and so on. So how can I do that? We are now able to leverage something known as the dynamic UCS. So you see this small icon on the bottom corner, which I have highlighted. This is the on-off button for the snap UCS to active solids plane. So that it's not only applicable to solids, but it is also applicable to point clouds. Now, when I start to draw something, let's say I want to draw a geometry. What is the geometry that I want to draw? I want to draw a rectangle, and I want to draw it on this plane. Okay, before I draw a geometry, let's say I want to section this point cloud at a particular plane, which is on the floor or on the wall or on some specific location. How can I do that? I click on the point cloud. Under the section plane, I have have this option known as two point section plane. So the moment I click on it, and when I move my cursor on the point cloud, it actually identifies planar objects. Although this is not a surface, it is a set of point clouds, but AutoCAD can now identify it as a plane. If the point clouds points in this cloud are in a plane, AutoCAD will actually identify this as a plane. And now when I click on this selection, you see that it has actually highlighted a plane. Although there is no plane there, or there is no surface there, it has still been able to select that as a planar object. And I click. Now the section plane was created exactly at that point, and the section that you see is exactly at the level of that planar selection that was made, and that was on the floor of that stage area. I am going to call it that area the stage. So this is a new function where I am able to leverage the dynamic UCS with point clouds also. So I'm going to use the same function now to align my point cloud, or maybe just wait. And is there anything else that I can do with this? Now see this building here. This is not particularly in proper alignment with this other area. So this is at an angle, okay, and this is how perhaps the building is at the location, and I cannot change it. But I see a wall here, okay, and I don't see any windows. But I want to make a proposal for a window, because this perhaps is a very old building, and I want to renovate. And at the time of renovation, I also want to create a window, a opening in the wall there. So how can I actually create a window? I have to draw something there. I have to perhaps create a rectangle. So I'm going to use the same functionality of the dynamic UCS and try to draw something on the wall. So if you see now that I can actually sense the wall, and this behavior will be available only when the dynamic UCS is turned on. I'm going to switch it off. In fact, if you see, my OSNAPs are turned off, and now I've also turned off the dynamic UCS, and I'm going to try and do the same thing. It will not work. So I'm going to switch on the dynamic UCS, and I'm going to create a rectangle. And now I can, this rectangle that was created was exactly on the this was exactly on the wall. As you see, it was perfectly created on the wall. I can try and do something here on this wall as well. Okay, so I'm going to do an extrude. Now I'm finding it a little difficult to see the rectangle which I just created. So I'm going to use, I clicked on the point cloud and I got this contextual ribbon for the point cloud, which gives me some additional tools to manipulate the point cloud. So I'm going to switch on or increase the transparency. Now I see the rectangle pretty clearly. I click on it and I use the same tools that I used earlier to create a geometry. And now let me switch back to the old transparency here. So now you see that I have created another object which is exactly aligned to the exact to the point cloud in a way, and we experienced a behavior which is very similar to if the objects were not point clouds but were actual solid geometry created in AutoCAD. So this is an intelligent behavior, and AutoCAD can now actually recognize planar faces and a few other things like, well, I want to recreate this wall here. Okay, and if I look at the top view, this wall here is at a curvature. Okay, so I see the wall which is actually curved. Now I want to recreate this wall. So what are the ways in which AutoCAD can help me now? In 2016, I have some new snapping methods. Okay, I can actually snap to point clouds. So that is, of course, not new. I could do that in 2015 already. But now in 2016, I have some additional settings, like these are the various options for the point cloud, and I can actually snap to an edge, for example. So what can I do by snapping to an edge? I can, let's see. So I'm going to switch on the 3D snaps, and I'm going to draw a line. I'm going to draw a line, and I'm going to actually snap to the edge of two planes. Well, this is very interesting. I really like this because I am actually snapping to it as if I am snapping to the edge of a solid model. Okay, this is not a solid model, this is a point cloud, and I am able to snap to this point cloud and draw a line. So I could exactly draw a line on the edge of the wall. So let us actually look how it, see how it looks like. So this is the line which I drew, which is exactly on the edge, which I can now leverage to create further geometry. But to create any geometry, any revolved surface, I need, of course, the section that I need to revolve, but I also need a center line. So how do I create a center line? I have another new snap option, which is the center line here. for the point cloud, and I can now use this to locate the center of that curved wall and create my center line. So I'm going to use the line command again, and I'm going to just move my mouse over the wall, and you see that it is actually highlighting the center line or the center of that wall. So I'm just going to click and I'm going to start my center line. I'm going to just create a line here. So I have got my center line, I've got my section, and now I'm going to use the revolve command to revolve this line about this object. So I am able to select an object. I'm going to, okay, so this is the opposite direction, so I have an option to reverse it. So I can now create a curved planar surface, and the curved wall there very accurately, and which will now help me to create additional geometry exactly by taking references from the point cloud. So this is so there is these are a few new OSNAP methods. There is one more which I would like to mention here is the corner, and with this I can actually select the corner of a point cloud. So I believe I'm still on. I saw a small discontinuity of the internet, but I think I'm on again. So now when so the other OSNAP method which I was talking about is the corner, and I just switched on the OSNAP here with the corner of point cloud selected, and I am about to draw a line. Okay, let me actually change the transparency back to 0 so that I see the point cloud properly. And let me show you how the corner OSNAP would behave. So you see that I can actually snap to the corner of 3 planes and create a geometry. So again, a very interesting way of selecting geometry and creating geometry by referencing various specific areas of the point cloud. Now let us let me close this and reopen it, and I want to show you how I would rather first align my point cloud correctly so that I can work on it exactly the way I want. So let me switch off the orthographic view. Let me, yeah. So now if you see this this area, when I'm seeing from the top, I clearly, if I align it with an edge of my AutoCAD window, I see that it is definitely not correctly aligned. So I want to first properly align it. So how can I do that? I am going to use the dynamic UCS. I'm going to use the dynamic UCS and I'm going to draw a rectangle which will be, of course, aligned to my X and Y axis. But I want to draw it on the roof of this object. So I'm going, with my dynamic UCS turned on, I am able to sense the roof. Okay, so I'm going to use sense this roof and I'm going to draw a rectangle. So the rectangle is not clear to me. So as earlier, I'm going to make my point cloud a little more transparent. So now if you see the top view here, I clearly see that the top of the roof is not aligned with the rectangle. So now I want to align it. So I'm going to use the align tool, and this is the object to align. So I selected the point cloud, and I'm going to say which is my first source point. So how do I get the source point? How do I exactly snap to something which can become my source point? So I'm going to go to my object snap and select the edge as an option and switch on the 3D object snap, and then I'm going to select at the edge and I'm going to refer this as my origin, and then the next I'm going to switch on my 2D snap and say that this is my destination. Again, the same, I'm going to do it a second time for another part of my geometry here. And I'm going to select a point on the edge of the point cloud, and then on the next one would be this corner of the rectangle, and I say yes to my selection. And now if you see, my point cloud has been correctly aligned to that rectangle. So now I am in a position to better manipulate the point cloud for further consumption. I am going to do this one more time to align it in this plane as well. So I'm going to switch back to zero transparency so that I can see my point cloud correctly. So let me switch off all the snaps, and with my dynamic UCS on, I'm going to create another rectangle here on this face, on this side face. So I have the rectangle created. I'm going to delete that earlier rectangle because I don't need it anymore, and I'm going to switch on the transparency so that I see the rectangle clearly. And I use the align tool again. This time I have to again switch on the 3D snap. So this is the object I would want to align, and I select this edge and align it with respect to my the corner of the rectangle. and I again select the edge again. Let me switch off the 2D snap so I can correctly select. Yeah, so I have let me see whether I have switched on the correct. Okay, it is selected. Let me see if I switch this on as well. Yeah, so I believe I select this and I want to select the corner here. I say yes. Now my point cloud is correctly aligned. Okay. So now with this alignment done, what I'm going to do next is I'm going to okay, so let me switch back the transparency. Now I'm going to create a cropping boundary which is very precise, and I can now save this cropped area for further